welcome to this BCS Midwest Branch webinar. My name is Fred Long. I'm chair of BCS Midwest Branch. And again, apologies for the slight delay in getting organised. So it's my pleasure to welcome Tally Roberts to give this webinar. Tally is an outreach officer at Aberystwyth University, involved in providing educational resources and workshops to children of all ages in the departments of the Faculty of Business and Physical Sciences. So those departments are business, obviously, computer science, information studies, mathematics, and physics. So without further delay, I should say, yes, please will everybody remain muted and keep your video off until the end of the webinar. If you want, you could put questions in the chat, and then at the end of the webinar, you can unmute and turn on your video. We will have a question and answer session. So over to you, Tally.
Okay, thank you, Fred. Good evening, everyone. As Fred has done a fantastic introduction for you, we're here today to have a look at online educational resources. It's a personal review. I shall start just quickly by just going over who I am. So I am a qualified secondary school teacher in the sciences. I've now the outreach officer for Aberystwyth University, as Fred kindly explained. Computer science is one of the 5 departments that I cover. And today we'll be focusing on the computer science side as part of Robotics Week. So what are we going to be looking at today? Well, what I wanted to do was give a review of what free in-browser software there is available to support education. We'll be looking at using online and in the classroom, and also classroom options that are available for remote teaching. So there is a note on the bottom there. This is all from personal experiences, personal review of what I've discovered has worked and hasn't worked. We are not affiliated in any way with any of the providers that we mentioned this evening. Okay, so why do we need to look at online free resources to help teaching? Well, the obvious answer is COVID-19 made us realize that these tools are required at times. But at the same time, it made us realize that some of these tools are really handy to have outside of lockdowns and homeschooling. So we needed it for outreach to continue our educational resources and provision online. We wanted to host remote events in all the departments that we have. So we had to come up with ways of hosting events for people to join online. My workshops. So before COVID and now that we're out of lockdown, I used to go into schools and clubs, just returning to that now to deliver educational workshops to kids of all ages in various different locations in person. However, with lockdown, needed to move them online and find ways of offering those same sort of activities in a virtual environment. We also have a robotics club that we didn't want to have go sort of offline as such. We needed to get that back online so that we could continue teaching kids after school in our club about robotics and programming. So let's have a look at what we discovered. So if we first look at basic programming skills, I have included Scratch on the list. Scratch and Scratch Junior are fantastic starting points. They're already used in a lot of primary schools and secondary schools to help support learning about programming. I'm not going to cover too much on this because I have not had the need yet to investigate the Scratch classroom capabilities. However, I have done it with BBC microbits. For those of you who don't know what BBC microbits are, they are relatively affordable computers that have been manufactured with the support of the BBC for learning to program. And they are small computers that can be programmed using blocks very similar to Scratch. So what I've going to do this evening is I've broken it down into these little sections, and then we're going to look closer at each of the parts on it. So, microbit. When you first start out with microbits at primary school and in secondary school, there is a MakeCode for it, specifically designed for the microbit. It is available to do in browser completely for free, or if you're able to, you can install it as a desktop application as well. It is block-based programming. And I'm going to actually show you what it looks like. So I'll load up the screen here. This is the MakeCode for the microbit. Now, the thing is this is really good for having, it already has tutorials here that will take students and learners through how to make certain programs, including ones for the version 2 microbit. So be aware of what version microbit you have. The easiest way to check which one you have is whether or not the logo in the top center is gold in color or colored. If it's gold, it's a touch sensor, and therefore it's a version 2. As you can see, there's loads of resources that have been made available, loads of programs that are already there for people to play with, and lots of ideas for how to expand it into making little sort of robots that are powered by the microbit, as well as science experiments. So how easy is this to use? Well, if you're using it on your own, I'm going to open up a project. On here, you've got your programming area, which is all blocks, very similar to Scratch. You can program it on this side. You can have them make pictures. You can have them write the whole program. It even goes into producing their own variables to use with various logic and maths. On the very basic level, we start off by having them create a start sequence and then create testing inputs and outputs. So we teach them about what an input is and what an output is, and we go through how to set it so things happen that are different on each block. So we can do this. And then there's this fantastic simulator in the corner that will allow them to test their program. So you don't actually need to have microbits in your classroom for this. You can all do it in simulator, and you don't need to worry about having the actual kit. So it's very simple, very easy to use, but how to use it in a classroom? Well, the answer is there is actually a classroom setup for this. So as a teacher or an educator, if you've got more than one person taking part in your session and you want to be able to see what's going on and have access to their work, there is this. This is the microbit classroom. It is in beta testing phase, and we have ourselves also given some feedback on it. You can set up the name of your activity, so you can put your class name in there or whatever you want to call your activity. You can set it in MakeCode, and then you can simply launch a classroom. Okay, so what is the classroom? It gives you a nice step-by-step as to how to go about using your classroom. It gives you this dashboard, which shows you how the students can join. So in this case, in every case, the URL to go to for students is microbit.org/join. But then the classroom name and the pin is generated at random when you create the password. When you create the classroom. And you can see here, you can see that you need to select red, frog, ice skate, stopwatch, and the pin number. I'm going to quickly copy that pin number because I also have student view. So this is what the student will see when they go to that microbit.org/join. And then they have to drop down menu, scroll down to find the right items to match up, which would be good if I could remember what they were. Ice skate and stopwatch. And then the pin number. And then they can join the classroom. Hopefully. Just double check. I think it's because I'm on the same computer. Oh, there we go. I've got one of the members of staff is helping me out. They've joined the classroom down here. So you can see which students have joined, so you can keep track to make sure you've got all the laptops have connected okay before you leave this sort of screen for them. Then you can set a program. So you can create a program for them to start with, whether you want to have them debug something or just want to put some of the blocks in place to help them out. That's up to you, or you can leave it blank. You can then share the code with all the students, and that will give a notification to say the code is being shared. And then you can have a look at what the students are doing. I'm going to see what she's up to. So on this screen, we can see that's the program that I sent across, and we can already see that there's some changes being made by the student. Disadvantages to this is I cannot influence what is going on with the code. And if I was to then send another piece of code over, it would wipe this over if I was to share a new code over. So I cannot interfere or interact with what they are currently doing. The only things I can do is I can stop them making changes. I can change their class name if it's not a suitable one, but I cannot access their program and help them in sort of collaboration mode. So if I quickly flick back to presentation. So we've gone through, you've got the actual microbit for individual work, or there's a desktop app again. You've got block-based programming. The simulator is included, so you don't have to have microbits to run it on. There's an online classroom with a library of resources available through the BBC and through MakeCode. But there's also the option of having programming done in JavaScript as well. Now, if you were being eagle-eyed when I was setting up the classroom, there was an option to set up a classroom in Python. But unfortunately, you lose the simulator when you set it up in Python, and there is a better alternative we'll be coming to shortly. Okay, so the disadvantages that we've come across for using MakeCode is there's no collaboration. You cannot live interact with the student's code. The classroom content can be time consuming to retrieve. The methods of saving the files are not as programs, it's as images in a Word document. So you end up having to shut all the students down, make sure they've all logged out of it. And then you have to manually go through and copy their code into your program, into the teacher's account, and save them as individual hex files, which is the format that microbit files are saved in. And that takes time, and it takes a good 10-15 minutes at the end of a lesson just to have a copy of everyone's program so they can continue working with it outside the classroom. Work done in the classroom is not saved to the students' computers. There aren't any components in the simulator. The simulator is simply for the microbit. And only a single educator within the classroom can actually view and do anything within the classroom. So the collaboration is limited to one member of staff, which would be fine in a generic sort of classroom setup where the teacher can lead it. However, for us, it was a bit problematic because we have a number of staff run our robotics club, and it's very helpful to be able to have multiple people viewing people's code at the same time. Okay, so that's a very quick basic overview of MakeCode for the microbit. We then move on a bit to further programming skills, and you'll notice the top one, whoops, go back. The top one is, again, the BBC microbit. You also have Arduino and Python. So we're starting to look at written languages as well as the block programming. So why have I put BBC microbit back on this list? Well, the microbit has more functionality than just being a single computer that can be programmed to show faces or make sounds. If I quickly flick back to this one and go back into here, we have pins on a microbit. It can be connected to other components, which will allow you to use it for science experiments or to make circuits or, well, programmable circuits. Now, in this version, if I was to use the pins, I could have it so, oh, no, wait a sec. Have it so it activates a pin on button A. If I can quickly find that, here we go, pins. So you'd have to explain to them about pins without being able to demonstrate it for them. So I want it to turn on when I press button A, and I want it to not put power through when I press button B. I want it to turn off. Let's say there was an LED attached. In this case, I would want it to then turn off the LED when button B is pressed. So if we have a look at the simulator, there's nothing shown here. All there is when I press A, it shows that there's power going to pin 1. And when I press B, there isn't. So it makes it difficult to explain what those pins are doing because you cannot see the components. The only component you'll ever see is if they start to include sound on their program. Let's see. And then you'll get this. And the reason you get this is it's just showing it's on an audio jack, because the version 1 microbit, which would have the colored symbol up here, doesn't have a speaker. It would have to be connected to headphones via an audio jack. So we wanted to have them build a microbit circuit where they could have components. So what we did was we went investigating and we discovered the microbit on Tinkercad. Again, you can use block-based programming, but the simulator includes additional components. There's an online classroom again, so we've got that fantastic tool of being able to set an activity and also be able to view what the students are doing whilst we're going through it. It also has Python option. Let me just demonstrate this program for a moment. Let me see if I can get back to it. So go to Tinkercad. Now, the first thing is that if you are a teacher and you have a Tinkercad account, you need to make sure it's an educator's one, because at the moment when you go into Tinkercad, all you will get if you're not an educator on it is join a class. So if you want to create a class, once you've made an account, and that is one of the disadvantages, is you do need to make an account for Tinkercad. You need to then sort out your settings to make sure, oops, I hit the wrong button. You then need to go into your settings to make sure that you are an educator. Now, I found this earlier and now I can't. There we go. So if you haven't set it up correctly, you need to come into here and set your role. I am an educator. Let's go. Save the changes. Fantastic. So now when I go back to this, which is my home page for this, I can go into classes. And hopefully I would then have the create a class, which it hasn't quite updated yet. So I'll quickly show you on this one. So teaching tab will be here, and then you can create a new class. So you can create a class. You can again have a classroom name. You can then say what age level they are that you're doing it with, or the subject that best fits. I'm not going to do any of those. I'm just literally going to name it demo. And then in here, you get a class code, which you can share with students for them to join the class. So if I was to copy this class code and then go back to that one that wasn't on teacher mode, they can either have an account or they can actually do it from the homepage. Students don't need an account to join a class. Their homepage will allow them to join it without a temporary, but you'll need to set them a nickname. So as with any of these things, you do need to spend a bit of time getting familiar with the software before using it. No, that didn't work. There we go. And it always goes wrong when you're live demoing something. So when your students are here, you can add a seat, which is what I meant about listing a seat, which would allow them to join without needing an account. And you can give them their name and just tell them that's the nickname, and give them a nickname that they then have to enter to confirm that they are who they say they are, and get them into the class. In the class, you can put activities, so you can create a circuit for them. You can create the microbit to get them started. And then you can see the designs of all the students, as well as all the ones of the teacher. So for the teachers, I can see it. But if you notice, this is the main advantage that we found to a Tinkercad over microbit, was that you could have co-teachers. You could sign more people up as admin to your classroom. The only limitation being only the owner can add activities. So if I now go back to demonstrate what is Tinkercad to start with, we go into circuits and create a new circuit. This is Tinkercad. Now this is Tinkercad for electronics. So we've got the microbit here. We can click a microbit across. We have microbits, but the difference with this one is that we can then connect components to it. I'm going to quickly make alligator clips because that's generally what we use when we're doing Tinkercad. So let's see if I can get this to connect. So I can connect pin 0 to the light. I can connect the ground to the light, and then we can code it so that at the moment, when we start, it will just show the smiley face. What we would like to do instead is make it like we had earlier. So one button A being pressed, and then one for button B. We can then set the output. So here we go. Let me find it. So pin 0, we'd set it to high on there, or you can set it to, you can use the binary or the high-low, depending on which one you want to use. So I've written the same program I just quickly had produced in the microbit for when I press A, I'm hoping to turn this light on. When I press B, I'm hoping it will go off. So if I then go into start simulation, There we go. When I press A, I really hope this works, unless I've wired it up wrong. Then we find that I've got my wires the wrong way around. Give me a moment. Let's make a mess of my program here. Okay, so hopefully when we start the simulation now, when we press A, it lights up. There we go. And when you press B, it turns off. The other advantage of this is you do get these warning messages. So there's a warning message on this. Let me move this out of the way. This is the way that you can tilt it in here. There's a warning message, and it tells you that the reason is that the current through the LED is too high. At this moment in time, it's just going to shorten the LED lifespan. If it was too high, it would actually show an explosion sort of symbol to demonstrate that you just blew out your LED without actually physically having to replace your LED. So this was the way that we went about covering the shortfall from the MakeCode. We basically went, right, MakeCode is a great starting platform for learning how to program the microbit as a little computer device. But then Tinkercad, we decided, was the better option for being able to produce circuits where we could start to introduce components. We could start introducing the idea of breadboards and other sort of parts to the circuit for when you want to use a microbit as a controller for a robot. The other advantage of Tinkercad is that even in classroom mode, you can have your two separate microbits at the same time. The coding, as you see, it is in block format, but you can also have it in both blocks and Python visible at the same time. So you can see what it looks like in Python as well as in the blocks. You can do it just in blocks, or you can have them do it purely in text. Now, if you notice the warning message, if you've started the program in blocks and switched to text, you will lose your program. Okay, so that's using Tinkercad for microbit. What are the disadvantages? So let me just quickly go back to there. It uses the block-based programming. It had the simulator with additional components, has an online classroom with collaboration with more than one educator present if you wanted it, has the Python option. But what it doesn't have, what the problems are, is that you do need to have an account with Tinkercad to use as a teacher. It is a slightly different block programming language to MakeCode. It is very similar, but not the same, which can cause some confusion. There is no in-program guide to how components need to be connected. So you need to know a lot about electronic components before you start to put together circuits with students. And the other one was only the owner's account can add activities. Okay, what next? Well, now we stay on Tinkercad because this is also suitable for learning about Arduinos. So let me delete my microbit. Get rid of all these components. There we go. We also have the ability to drag in an Arduino and build a circuit around that. The difference with the Arduino is the code. You can still do it in blocks. You still have the option of switching between blocks and text, or text. And this is an introduction to, well, it says at the top, C++ or Arduino C. And we can start to take them through how to build up a programmable circuit with an Arduino. Now, we've used this at a number of different workshops and events. I think we've used it the last couple of years during Robotics Week as an online workshop, building sort of like smart home circuits programmed with the Arduino. So we like this tool simply because you have the simulator, you have the components, you can put it all together. It is very similar to using the microbit. Again, block-based programming, simulator, online classroom. You can have this as an activity on online classroom where you can access it and live change the design of the circuit. You can add comments to the circuit, or you can put comments and alterations into the coding and it will live change the student's work. And it has the Arduino C option on there. The disadvantages is that, again, same as before, teacher needs to have an account, no in-program guide to how the components can be connected. The block programming, when it comes to Arduino, loses some of the functionality. You can't do anywhere near as much with an Arduino using the blocks as you can with the text programming. Only the owner's account can add activities. And there's one other thing I want to put here is that you can lose a lot of time if you are like one of our organizers who has to have all their wires perfectly tidy. That in itself is a time-consuming activity, building up circuits, especially the more complex ones. I can demonstrate quickly a complex circuit that we made available. Let me see. So we've got, go into this one. I'm hoping this is going to work. There we go. So you can see here, we've got a circuit here that we provided as a template. We've got comments on it to show what each of the components are and what they do. And what this is based on is this is based on an Elegoo rover car. We were trying to make a simulated version of the robot for them to start learning to program a robot without physical access to the robot. And as you can see, this is done by the person who can spend a long time getting lost making wires tidy. So Tinkercad has definitely won our praise in regards to making teaching easy online. But then we get to learning about Python. Now we touched on Python with the microbit. If you want to do Python in microbit with a simulator, you have to do it in Tinkercad. Otherwise, you can do it in MakeCode, but you lose your simulator and you use the ability to test the program without having to put it onto a physical microbit. So what about Python using Minecraft Education? Now, this is an interesting program that kids love. Minecraft is a big fad. And if ever they see a Minecraft icon on your computer, they will instantly gravitate towards it. It is accessible to anyone with an educational Microsoft account. There are libraries of tutorials. I'm not going to demonstrate this one today, just simply because it's quite hard to do on a shared screen. I discovered that. It is very appealing to the learners. There are pre-designed educational worlds available within it to teach them certain concepts. And there are also block coding options. The Python option, you can actually have a complete Python editor. There is step-by-step instructions for various different things that they can do within Minecraft. It is a really fun way for them to learn to program by getting their little robot to build the structures for them from a list of commands. The disadvantages are that it can be time-consuming to set up in a way that the students cannot break it too easily. But also, if you want to create your own classroom environments, you need to dedicate hours to it. This is why, if you are to use it, I would generally say start off using already existing classrooms that other educators have put together. There is a whole collection of them on the Minecraft education webpage. I have put in here knowledge of the software necessary. Don't take that lightly. Basically, most students know Minecraft inside out and back to front. They already know all the cheats, all the shortcuts. So as an educator or a teacher using this software, you need to be aware of them all yourself to make sure that they're locked down or inaccessible unless you want them to be. This was the main problem for us, and the reason we haven't done much with it is that it cannot cross between educational institutes. What I mean by that is if we were to set up a classroom and host it for a workshop, even though Hub Cymru users have access to this program free, and because they're on the Hub Cymru Institute login, they cannot join a server run by Aberystwyth University Institute. So we can't actually host a server for kids in a school, and we also can't log in to a Hub Cymru account. So for us, it was not really a practical thing for us to do. That doesn't mean that we won't be looking at producing classrooms that can be shared for teachers to use instead. It just means that we are unable to do Python workshops using Minecraft Education online. And the other thing, obviously, is that you do need to have it installed. I did mention that any Hub Cymru account and anyone else with a Microsoft Education account can log in and use it for free, but you do need to install the program. Okay, so that's enough about Minecraft. How else can we teach Python online? Well, we came across this one, coding rooms. Now, coding rooms really surprised us with how well it worked. It's one of our more recent discoveries. I'm going to go load it up. So in coding rooms, you can make worksheets. Let me load one up. These are worksheets that we created for our robotics club. And again, we've set it up as worksheets to work in a classroom. We can then share the join code and or a link that will allow you to join the Python, allow you to join the workshop or the activity classroom that we've created. You can see here, I believe, yeah, I've got both Thomas and Patricia have connected to this one to have a look at it. In here we have, well, this is what we did. We did an introduction to Python, and I'll just show you what we used. We produced these worksheets. Now, there are two types of worksheets you could produce, sort of like a work through it text one with these lovely terminal screens and consoles that allow them to run the program, see what it does, but also allows them, I'm going to wait for that to load. It takes a moment the first time round, but it also allows them to interact and change the program to see what differences that makes. And then they can run it again and see what the difference is in the console. So to start with, we gave them a couple of worksheets. The students we were doing this with had already been working in Arduino C. So a lot of it was teaching them the differences between the two languages to introduce them to working in Python. So you see here, we've got recap on Arduino C data types compared to Python data types. So this is one thing we could do, is there are worksheets like this. But you could also do things like this, which I don't know what it's called, but I kind of like it as a step-by-step guide. So we gave them instructions for how to write a program, and then they had the program here. And if I go to this one here, for example, this here goes through step-by-step the information needed for this particular activity. There's obviously extensions as well on here. They have some code already in place. This is what they'd actually been building up until this workshop. We can also attach images and other files within here too for them to be able to access and use. And we can also run this. Now, this one was one that used the Pygame library. We didn't need to install the library anywhere. It was already accessible within coding rooms. They already have the library stored in it. This particular one allows us to have a game screen, so it doesn't run in the console. And now I really hope that there are no bugs in this code. Fantastic. So we have a desktop where we can produce a virtual desktop that they can then access to view their program operating. I'm going to keep it small in the corner at the moment, so they can see their games. So if I open this up now, oh, it's going to take a while. There we go. You can see that this is what they were producing at this point. They've got a little character that walks backwards and forwards and can jump. And there we go. So hopefully that shows you what you can do. Now, this is obviously from the teacher's point of view. I can go in and I can edit any of these comments. I can insert multiple choice questions. So if I go back to the creating a game screen, just to double check their understanding, you could put in little multiple choice questions. You can see which one's correct here because this is a teacher view. But from a student's view, hopefully my student view will work. Just give me a moment. From the student view, they get the list like this, so they can work out where they want to join. Which worksheet they're up to. It will also tell them if they've already completed. You can see not yet submitted, so I know that I haven't done any of these yet. And then when they go in, they can view the assignment and they can go through it. And they can work through this. Now, it is possible to set points for each of the pieces, and it is possible to also tell it what the points are rewarded for. So here I can do one of these. So if I select that one, and then check my answer, it will automatically grade it and tell me I've got it correct. You can have it so it will also auto grade these programs here, which is great because they can then just hit submit and they know how well they've done. They get the number of points at the top. And then once they've submitted, you can put a review, you can put feedback on from the teacher's side. You can go through, you can write comments into the text for them to see. Talking about writing in their text, the teacher can live collaborate again, so they can come in and they can take over the program. And then they can go through and they can either put in a comment to let you know what you need to change, or they can actually help you work out what's missing. So coding rooms was a nice surprise for us, and there's lots of good things we can say about it, but I should also mention the negatives about coding rooms. So I think I'd just double check. I have covered all that. Oh, it's also not just for Python. Coding rooms covers almost any language you can think of that you might want to be teaching or learning. There are online classrooms that you can download. There's a whole library of already existing programming worksheets and courses that students can work through. You can grab a copy of that as a teacher and then set up a session with your class using just those worksheets. You can lock down worksheets to make sure that they don't jump ahead, or you can lock down ones you don't want them to do and they won't be able to see them as a student at all. Okay, so what are the negatives? Well, for a start, all users for coding rooms need an account. They need to log in to the program. 2, there are paywalls. I don't know if you noticed when I was in my teacher mode, I had that orange bar across the top. I accidentally activated a 30-day free trial of the premium subscription, but that was after I'd already created these worksheets, multiple choice, and all of this was all available in free mode with no being forced to actually pay for anything. Yes, the paid for mode gives you more options for different things. You can have multiple choice with more answers, for example. If I quickly go in here, it gives me a bigger range of things that I can add. So yes, there are paywalls involved. I can't tell you how much it costs because they don't say, which probably indicates that if you have to ask, you can't afford it. So it might be something to look at as an institution if you did want to really make most of this. But yes, free gives you enough functionality to run some really good interactive worksheets on it. If you are producing your own worksheets, it is time consuming to prepare, but that's the same for any worksheet you're producing for a lesson. And like the MakeCode, only a single educator has access to be able to overview the student's work. So if you were needing support or had another educator in the room or in the workshop, there's only one who can actually access what they're typing. I should also, but the collaboration side of it makes it really handy, and you can copy someone's code. If you have another educator in the class, you can copy the code across to them as a student and ask them to look at it for you. The single educator is removed on premium, but every one of your educators needs to therefore be on the premium package. Okay. So I've had a look at, we've gone through all the basic programming style environments that we have chosen to use and why we chose to use them, but also where we found errors with it. Let's have a look at some other skills that we've been teaching virtually related to computer science. So electronics. Now I have touched on this, and no surprise, it's back on Tinkercad. Tinkercad for electronics is fantastic in regards to the fact that you can make circuits, you can make programmable and simple circuits. So if I go back to Tinkercad and we go into circuits and create a new circuit, just to demonstrate, you don't have to have a microprocessor, you don't have to have a microbit, you don't have to have an Arduino. You can just simply show them how to make a circuit with an LED and a 3-volt battery. You can also demonstrate what would happen if you put a 9-volt battery attached to your LED, and that would demonstrate that the LED can't take it. There are pre-made circuit assemblies to help. So I actually have, there we go, there's a copy of the coin battery wired up to an LED, which you can just go straight into the simulation for. You can see it is warning that the current is too high. It's not going to blow the bulb, but it will reduce the lifespan of the LED bulb. You can change the color of the bulb if you wish. Got to stop simulator to make any changes. So, you can change the color of the bulb. But you can also introduce, there's a spin circuit that you can have as well, which is just showing the on off for a battery. So we start the simulation, you can turn it on and you'll see 97, tell you how fast your motor is turning. You can turn it off. So there are some circuit assemblies already there. I'm going to have a quick look at this one. So you've got a move sensor on that one. So you've got different ones that you can use, or you can make your own. You also have the ability to add, let me go here, voltmeters and ammeters. So if you don't have access to classroom sets of circuits, or you're offering this as an online session for them, for students, you have all the stuff you need to make a basic circuit. I'm going to move that a moment. So you've got your resistors, you've got your light bulbs. One thing is, it is an American, so your light dependent resistor is called a photoresistor, but it's exactly the same sensor. There are lots of different things in here to wire in. You can just put in a standard light bulb if you really want to go for just teaching the electrics on the circuits. I'm trying to find what I'm looking for whilst talking. Here we go. So you've got multimeters here, which you can set as an ammeter or a voltmeter to measure the current or the voltage of your circuit, which means you can do those sort of experiments that you do to test what the voltage difference is and current differences in a parallel circuit and in a series circuit. You can actually do that all in here, and every student can then hopefully see it in action, and you don't have to worry about having enough electric electric circuit kit in the classroom. So yeah, we like this. The only major disadvantages, I struggle when we start to look at things like gates and things, because these are the gates on here. I mean, looking at one of those, I would not have a clue how to wire this up. And it doesn't really help. It just labels them as what's power, what's input, and what's output. I don't know enough personally about circuits to be able to use this, but I do know what an OR gate is, and I do know what, I know what the gates are. I know what they do, but it's going to be very hard to demonstrate it and use it without knowledge of how it's represented here. And as I said, there's not really much in the program to tell you how these things connect to the circuits, how you need to connect them. You'd have to experiment and try them out or know them very well. There is a lot of information online by educators who have used Tinkercad. You can find plenty of resources by searching for Tinkercad lesson plans with electronics. There is a lot out there at the moment to support. So again, you can do it in the classroom, so you can have them doing the circuits in the classroom. There we go. So we're back to the same problems we had before, with the extra problem of all the components are your complex electronic versions of those components. For example, the gates, as I showed you. So you do need to be versed in electronic components before trying to lead a session using them and helping students make sure they're wired up correctly and doing what they're supposed to do. Okay, so what was next? 3D design. So 3D design is something we did as a sort of part of a project that we had our club doing. We had them designing a website, and then, well, we had them designing their own robot and then designing a website to advertise their robot and to make a blog for what they were producing. So to be honest, this is how I first knew of Tinkercad as a 3D designer for making models. So we've only looked at this platform here, which is the electronics, programmable circuits. But if we go back, we can also do 3D designs. And you can have anything from simple shapes through to really complex ones. If I quickly grab a new design, it is slightly different. You've got a workspace, which is measured on graph paper. So you can see the size, 1 centimeter squares on here. And you have shapes, and you have lots of different shapes. These are just the basic shapes. And you can drag these shapes onto the stage, and then you can manipulate them. So you can merge them together. You can adjust how many sides they have. So I can make that rounder by introducing more sides. Same with the cone on top. I could then merge them together to make a different shape. So now I've got this shape that I can then manipulate and change and move around. You can rotate them. It's very easy to start getting going on this. I was quite amazed the first time I got some kids to get working on Tinkercad. The things they were producing just by working through the tutorial that's available. If they have an account, they can go through a tutorial that teaches them how all these things work. We've produced a few worksheets and challenges for them where it involves merging shapes together. And although it seems very simple, it is amazing what can be produced. So if I now go back to there, I'm sure you saw some of the more complex designs. I am not going to take credit for these. These are ones that have been made available public on a whole library of designs that are ready to use. So as we're in Wales, obviously, I've gone straight for the dragon. So this has been produced simply by using combinations of shapes in hollow and solid form to create a very intricate model, which can then be downloaded. You can then export it as what's called an STL file, which is what you need for slicing programs as a pre-step to 3D printing. But also, if you're working with younger kids with their shapes, they can design something in Tinkercad. And then there's this cool button here, which if we then change the detail, can actually give them a blueprint that will allow them to reproduce their model in Minecraft. And they, it's blocks of redstone is what it recommends for the color of the model, but we might want to change it to redstone ore, and that they can actually see their model as how it would appear in a Minecraft world and be able to reproduce it in there as a fun sort of side activity for those who have completed their designs. Go back. So let me just double check I've covered everything there. So it's simple click and drag. Shapes are easily manipulated. Designs can be saved as STL files for slicing, can be converted to Minecraft. And the classroom works also for designs as well as for the circuits as well. You can get them, you started with a set design, or you can make them, have them just create their own designs, and you can access them as a teacher within that classroom. You can see their designs, you can jump in and out of their designs and help them if they've got a problem with a sizing or a merging. The disadvantages are that, well, the teacher needs to have an account. That's the same as all the Tinkercad ones. There is some knowledge required to use the program. You need to spend a bit of time getting used to how to move around the stage, how to move the objects around, how to merge them, how to rotate, resize, scale, just so that you know you're going in, and if a pupil asks you a question, you know how to deal with it for them or how to take them through it. There are rulers on there as well that can be used. There's protractors, whatever you would need to design a 3D model. And again, only the owner's account can add activities to a classroom. Okay, I think I'm just checking the time. We're on good for time. I've got one more to cover, and that was web design. As I said, we did 3D design as part of a 3-part project. Web design was part 2, producing an online blog. So we wanted to teach them the basics of how to create a website from completely nothing at all, without using any templates or pre-existing framework. So we decided to give them a brief course on HTML, CSS, and JavaScript to have them create their own pages. Now, when we were looking for programs, this is the one that we found, and this is the one we used this year. It's called JSFiddle.net. And let me see if I've got this one open. Here we go. You can see I've been playing on this with someone else at the moment. It's a collaborative, free in-browser program. You can set up a file, you can then collaborate, you can have someone else then join it, and then they can edit it. You can both edit it live at the same time. You've got HTML can go in here, CSS here, JavaScript down here, although I think we've got script actually embedded in HTML. And then you've got a nice preview screen down in this bottom corner. So yeah, there we go. So someone else is active at the moment. They've just clicked run to show their script for the emoji explosions. So we were teaching them how to make their own web page, and they could see the changes live in this corner. Very fancy CSS going on. We've got some nice borders going on and things there. We had some difficulties with it. First difficulty we came across was that it's very fussy about browsers. It won't work in certain browsers, which is not very good when you're doing something with people in different homes with different computer setups. So it didn't work as well in some browsers as others. The other issue we had was we wanted to set up one of these for each of our students to use. And we did, and we shared links to each of the students, but we found that those links then linked them to the wrong file. It would link them to someone else's. There was no classroom where we could overview each of the files. And in the end, we ended up having to get all the students to create their own accounts on here so they could save their program to their own account, or sorry, their web page to their own account. and then send us, let us know what their usernames were so we could go and look them up and view them via their usernames. So we managed to go through and do it all using JSFiddle. But yes, we've decided next year we won't be using that one. It was just too problematic. It's great if you're doing 1 or 2 people, or you've got a team who want to collaborate on something. If you've got a team of people working together in different locations on a project, great, have them have one of these. Only one of them then needs to set up an account. They can share it with the link with all the others, and they can all work together live on that. However, as a classroom, wouldn't advise it. It was just too problematic. So I think I've covered the errors there. So all the users needed to create an account to make sure they could save their work and didn't have any problems. The collaborative option didn't work with multiple projects, covered that. Browser issues covered. Paywalls, it's also everything you produce on JSFiddle is public access unless you pay for it to be private. So anything you put out there is permanently out there. There's no way of deleting one, it seems. Not that we could find anyway. So what would we suggest using instead? Well, now that we've discovered coding rooms, we would suggest using that. So you can make exactly the same worksheets, you can use exactly the same setup in coding rooms, but using it for HTML, CSS, and JavaScript. There are a lot, again, there's already existing worksheets, step-by-step guides, activities that are available from other educators and from the coding rooms team themselves to take you through how to use the code and how to use basically the interface. The reason we would suggest coding rooms is it has that online classroom function, which allows you to collaborate live with each and every student in their separate files. It's got that interactive programming worksheets with those auto marking options again. So it marks for them so they can see instantly, they're getting instant feedback, they know how well they've done, and it saves time after the lesson on the marking. The disadvantages, we're back to exactly the same ones that we had when using Python. All users need an account. There's paywalls in place. It's time consuming to prepare if you're preparing a worksheet from scratch, and only a single educator can have access to all students' work. I think that covers our very quick whistle-stop tour of the stuff that we came across, the stuff we've used, the stuff we're going to reuse, the stuff we recommend others to have a look at and try to use, and also those that we've chosen not to use and why. If you want to find out more about how to use some of these programs, we are starting to put together resources for educators, for teachers, for parents, to be able to guide them through how to use these programs with their kids, with students. So all our updates and all our resources are in this top link here, which is fbaps-outreach-hub.dcs.aber.ac.uk. That is our outreach website. You can also find a link via Aber Hub on the aber.ac.uk pages. If you don't have time to write it down here, I'll keep it on the screen. The second link on there is that we also produce teaching resources. Thank you. It's gone in the chat. That link has also gone in the chat, so you can save it. We also have teaching resources available that we put on the TES website, which is the Times Educational Supplement. It's a fantastic place to look for lesson packs, for classroom resources, educational packs. If you haven't already come across it, go and have a look. There's a lot of stuff produced by teachers. I'm hoping that's that link now going into the chat too. We have our own area on there. It is called a shop, but all our resources are free. And then I've put on here my email address and my phone number, my work phone number, because if there is anything missing, or well, I would say there is stuff missing at the moment. I haven't put a lot of these guides up yet. They're in the works. But if there's something in particular that you want me to cover or would like to do maybe a CPD with, or a workshop with, or just to put together a pack and make it available sooner rather than later, please email me at that nar25@aber.ac.uk. Or alternatively, if you'd rather give me a phone call, you can on that phone number there. I'm hoping I've left it on the screen long enough that if you wanted that details, you've managed to grab it. The 2 links are in the chat. And all I have left to say now is thank you so much for listening. I'm hoping that everyone got something out of this. I apologize, it is quite fast, 1 hour to cover quite a lot. I mean, we spent hours researching what to use and then learning how to use it for our club and for our workshops. But we hope that this will help others save time in that prep work. I'm now going to return back. I'm going to stop screen sharing and return back to have an opportunity for questions and answers.
All right, thank you very much, Tally. Everybody feel free to unmute yourself and turn on your video, or of course you can put questions in the chat. So any questions? You overwhelmed them.
I think, there we go. Oh, thank you very much there. I've just got that message. Thank you. I mean, it was very brief, just touching on each of these things. The whole aim is to save other people time on doing this research of going, look, we've already looked at all those possibilities that are out there, and these are the best ones that we found so far. I mean, if any of you have a different program or a different thing that you've come across and used, please feel free to share it with us. We can't guarantee that we found them all out there, but we found the ones that we could.
Is there anything that you're sort of looking at for the future?
One of the things we're looking at for the future is obviously we want to look more at the coding rooms for other programming. I think there's a lot of potential in there. Even on the free version, there's a lot of potential for producing some interesting worksheets that can be shared with other places, with workshops, with clubs, with classes. And I think that would be a great place. Generally, I am just looking to put together as much support material for educating all ages in, well, any of the subjects that we cover at the university, but also helping educators as well. So this is why I was doing this session and why I'm offering to put together support videos for using some of this software in the classroom. I think I wandered off a bit off the answer of that. Did I actually answer the question there, Fred?
Yes. And any more questions?
Okay, I've had a question in the chat about the Tinkercad 3D and migrating the models across to Minecraft. It can be done. They have to have, there is a program you need to install to do the crossover, which can be problematic if you're doing it on school computers because of the restrictions on installing programs. So they would either have to use what they've produced in Tinkercad in that sort of Minecraft mode as a template and then switch between the two screens to reproduce it in Minecraft, or if you can get that bridging software, it does exist and it allows you to export it directly from Tinkercad into a Minecraft world. The disadvantage is if you transport it to the wrong place in your Minecraft world and there's hills in the way, it literally just puts the model inside the hill and then you have to mine out the hill to find your model again. So I would advise doing it with flat surfaces, not with the hills turned on.
Right, well, it looks as though there are no more questions. So once again, oh,
someone's trying to unmute to say they can't. If you've got mute, let me have a look.
So that's Emma. If I do that. Okay.
There we go.
So Emma.
Hello.
Hello. Yes, we can hear you now.
Sorry, I forgot to change the name on Zoom. I'm using my wife's account.
No worries.
So actually, it's Richard speaking.
Okay, the hello, Richard, rather than Emma.
Hello. I registered for this workshop late in the day, so I'm grateful that BCS sent out the reminder towards the end of the day. I joined as a parent mainly, with 3 young children, but I work in IT, and I concur with what you said about Minecraft. It's hugely popular with my 2 little boys who are 5 and 7. and often they leave me in their wake, really, with the way they use it. So I just wanted to kind of find out a lot more about the educational resources that were available. So I'm really grateful for the presentation.
I say if they've got a school email account, the chances are you can, I don't know if you've already realized this, but you can install Minecraft Education Edition, and they can use that using their school accounts without having to pay anything for it. And that Education Edition has a whole coding side to it. It's designed to teach coding in Minecraft. It allows them to create chicken rain, so they can make it rain chickens. They can have they get agents in it, which are little robot characters that they can program to move in certain ways and produce buildings. And they can do this using there's block programming for early on, so start to do it with little blocks, commands, and then you can take it up to the the Python commands as well. There's Python in there. There's step-by-step instructions within Minecraft Education, and on the website for the Education Edition, there is a whole library of things that other educators, teachers, or those just interested in creating these worlds have shared them. For example, there's one that goes through step-by-step challenges of how to use Python within Minecraft, and it takes them through little challenges where they have to write out the code, answer questions within a Minecraft world where everything else is locked down and they can't do anything without using Python.
Okay, that's helpful. That's great. Thank you.
Right. Any more questions? No, everyone quiet. So once again, Tally, thank you very much.
That's okay. If I could just say, if anyone thinks of a question later on, just hopefully email me. If you've got the links in the chat, my email address is also on the Outreach website. So there we go. And I'll say thank you very much, everyone.